I'm going to go over this lecture a little quickly, okay, because we spent some time on it already. All right, what we're going to do is we're going to learn about electric charges and their effects. Okay, so you're familiar with two kinds of charges, positive and negative charges, and those are the only two kinds that are out there. Protons have positive charges and electrons have negative charges. Okay. Here's an amazing fact. Protons are about 2,000 times heavier than electrons. Protons are made out of quarks. Okay. Electrons are fundamental particles. They don't have any structure to them. Again, these guys are 2,000 times heavier than these guys. There's no relationship between them. But their charges the magnitude of their charges are exactly equal to how many ever decimal places you want. Okay? So, anyway, so you have these two kinds of charges. So, over the next several chapters, we'll study properties of these charges and the effect they have. For the next 4 chapters, we'll have these charges fixed. They'll be at rest. And what you'll learn is they'll produce electric fields. These charges produce electric fields, and that's what we'll study. Okay? But in everything we study, the charges will be at rest. And that field is called electrostatics. Okay? That's what that subject is called. Okay? And that's what we're studying. All right. So the first 4 chapters are electrostatics, and then we'll get the charges to move. We'll study currents, and what you'll learn is moving charges produce magnetic fields. Charges at rest only produce electric fields. Moving charges produce both electric and magnetic fields. Okay? So if charges velocity is 0, they produce electric fields. And if they're moving, then charges will produce both electric and magnetic fields. Okay? Electric fields are denoted by E, and magnetic fields are denoted by B. Okay. You saw that okay, if you take two materials of the appropriate kind, here's rubber rubbed against wool. So what happened was wool atoms, these atoms gave up electrons, and these atoms attracted electrons. Okay? So this is called triboelectric charging. So this is charging by friction. Okay? So if you rub two materials, one of which is willing to give up electrons, another which is willing to accept electrons, you can charge objects. Okay? Again, that's called triboelectric charging. The amount of charge transferred is very small. Okay? But since the electric force is very strong, the effects are rather dramatic. Okay? And what this table lists is these are materials that are willing to give up electrons. These guys accept electrons, so these guys are called more electronegative. And when you rub this against that, these guys will give up electrons, and these guys will accept electrons. Yep. So that's what that list is. So if you take a glass rod and rub against silk, okay, any glass will give up electrons and silk will absorb electrons. The further out you are, the more dramatic the effect. Okay, the further apart you are. All right, so like charges repel each other and unlike charges attract each other. So two positive charges will repel each other and unlike charges will attract each other. So there are only two kinds of charges that are observed in nature, and that's why we call them positive and negative. If there were three kinds of charges, then you would have to call them 1, 2, and 3 or something like that. Okay. Or RGB colors like you have for quarks and gluons. Okay. All right. So we'll talk about insulators, conductors, and semiconductors. And I'll just briefly tell you about them. Right, so if you have a single atom, so for instance, here's a carbon atom. A carbon atom has 6 protons and 6 neutrons and 6 electrons. Okay. Now, so this is the lowest energy level for the electrons, this is the next higher energy level, and so on. The shells are energy levels. Okay. So if you have a single carbon atom, here are the energy levels. Okay. So these are the energy levels of these shells. Yeah. Energy is increasing. The lowest level is occupied by 2 electrons. This one has room for, this level has room for 8 electrons. Okay. It's got 4 electrons right now. Okay. And so on. And these guys are empty. Can you populate these levels? How can? I'm sorry? Say that again? Yeah, no. For this carbon atom, can you populate these guys? You could excite these electrons, okay? So the higher levels are empty, but if you shine light of the appropriate frequency, an electron will absorb this photon and get excited to a higher level. Okay? But anyway, so that's the structure. Now it turns out that what happens is if you take a whole bunch of these atoms and arrange them in a crystal structure, then each of those levels, what happens is each of those levels become bands. Okay. For this material to be electrically conducting, meaning if you connect a battery to this material, and for it to conduct electricity, what needs to happen is it needs to have, so that this band is called a conduction band, it needs to be partially full. Okay. If a material is insulating, electrically insulating, for instance, wood is electrically insulating. Oh no. Has anybody been watching the recordings? You've been watching recordings? Are the recordings scrambled? Oh, this thing gets weird?
I wouldn't trust it, yeah. So I'm gonna start a new recording and put 2 up again.
That's usually what desyncs the audio as well.
What's that?
Usually when it does this, that's what desyncs the audio as well.
Mm-hmm.